Now we're going to be talking about superposition and interference. Firstly, consider two objects. Two objects cannot exist at the same point in space at the same time. If you and your friend both try to sit on the same chair, there's a problem. But waves can exist at the same point in space and time. Waves can pass through each other. Spooky. What do I mean by this? Well, let's write an example. So if I draw here two waves, and they're, say, two disturbances on a string, and they're moving towards each other. What happens when those two waves collide is illustrated here. And as they pass each other, they move back in the opposite direction here. So what's essentially happened is that the waves have passed through each other, and the displacement of the waves have increased as a result of the two displacements. So if we say both of the waves have a displacement x, their resultant displacement when they're together is 2x. So the two waves overlap. This is called constructive interference. We can also, of course, get destructive interference. And this is what happens when two waves overlap that have equal and opposite amplitudes. We can draw this here. So we can have a wave travelling to the right and a wave travelling to the left. When they meet in the middle, they cancel out each other precisely. But then at another moment in time, t equals 3 seconds, minutes, you can see that they've re-emerged. So the two waves cancel each other out because of destructive interference. When waves cancel each other out or add up, this is called the principle of superposition. When two or more waves are simultaneously at the same point in space, the displacement at that point is the sum of the displacements due to each individual wave. Let's do an example to show you what we mean. So let's draw two wave patterns. So we'll have 5 points in time. T equals 0, 1, 2, 3, and 4 seconds. And we'll have two wave fronts. A triangular wave front moving to the right at 1 meter per second, and a square or rectangular wavefront moving to the left also at 1 meter per second. So at the top we have t equals 0 at 0 seconds, and this is where we start our system. So after 1 second we can see that both waves have moved. The triangle has moved to the right and the rectangle has moved to the left. Things get interesting at t equals 2 seconds. Now both waves are in the same place at the same time. They're interfering with each other, and in this case they're constructively interfering. So the sum of their displacements means that we get the resultant wavefront at t equals 2. As the waves move past each other, we can see here at t equals 3, and finally they separate again at t equals 4 seconds.